Hello viewers, welcome to today's session of food technology under which you will be studying about lipids. Let us start with the introduction. In continuation with the first two parts, let us learn about changes absorbed in fats with the effect of frying during storage conditions and the preventive measures for auto-oxidation. Let us also know about the processing technologies applied for edible fats and oils and different types of fat mimetics. In earlier units, you learnt about the definition of lipids, followed by classification and the analytical techniques used for evaluation of physical and chemical properties of lipids. In this unit, let us learn the following aspects. Fat is a principal component of the diet. It adds or modifies flavor, texture and helps in leavening batter and doughs. It also contributes to tenderness, flakiness of the product. It transfers heat to food while frying and prevents sticking of food. Sources of fats and oils may be animal, vegetable or marine, which may be manufactured in some combination in industrial processing. Oils used in margarines, spreads, dressings, retail bottle oils as well as frying oils are the largest market segments of edible oils. Fats and oils undergo certain undesirable changes during storage which result in spoilage. The major spoilage of fats and oils is rancidity. Various fat replacements attempt to mimic fat in mouthfeel and perception so that it is good tasting and low fat. Their caloric and cholesterol level are significantly less than fat. As a group of fats and oils should be used sparingly in the diet. With this, let us study the episode with the following important subheadings. First is effect of frying on fats and then changes in fats and oils which includes rancidity, lipolysis and flavor reversion, then technology of edible fats and oils and in the last fat mimetics. Let us start with the first one, which is effect of frying on fats. Frying food with melted fat or oil is a common cooking technique. Frying is a rapid heat transfer method that achieves a higher temperature than boiling or dry heat temperature. The characteristics of fats for frying include that fat must be colorless, odorless and bland and have a high smoke point. Frying of fat decomposes it and causes many changes to take place. Oil decomposes chiefly by 4 ways. The 4 ways are pyrolysis, oxidation, hydrolysis and food residues. Pyrolysis is a thermal breakdown and the cause for pyrolysis is heating oil with or without contact with food, and the changes which is absorbed is breakdown in molecular structure, that is fats will be broken down to fatty acids plus glycerol, in which these will be again broken down to free fatty acids and acrolein. The acrolein causes irritation to the eyes. The second way of decomposition is oxidation, and the cause for oxidation is hot oil surface plus oxygen which is present in the air, and the changes which is seen is molecular breakdown. Rancidity develops as and when the oil is heated. The third change is hydrolysis, in which water evolved from boiling food will come in contact with oil, and the change is decomposition of oil by water. The last way of decomposition is food residues, and the cause is food residues plus reheated oil, and the change is chemical changes in the residues as well as the reheated oil. They all cause lowering of smoking point and operating temperature of oils. Now, let us see the second section, which is changes in fats and oils. The stability of a fat or fatty food is important to maintain a fresh taste or odor during storage and use. The stability is related to the composition of lipid moiety and the changes it is subjected to. The presence of agents causing oxidation, which are pro-oxidants, or preventing oxidation, which are antioxidants, and the methods of storage determine their stability. Vegetable fats are usually more stable than some of the animal fats, even though the total unsaturation of the vegetable oils may be greater because of the natural antioxidants usually present in them. Now, let us see the first change, which is rancidity. Rancidity is the deterioration or spoilage of fats and fat containing foods due to lipid oxidation. Rancid foods and oils develop highly reactive chemicals which produce unpleasant odors and flavors and destroy nutrients in food. Rancidity is accelerated in highly unsaturated fats and storage conditions conducive to chemical changes. There are two types of rancidity. One is hydrolytic rancidity and the second one is oxidative rancidity. In hydrolytic rancidity, which involves reaction of fats with water and liberation of free fatty acids, whereas in oxidative rancidity, it is more complex and potentially more damaging reaction. The fat is oxidized and decomposes into compounds with shorter carbon chains such as fatty acids, aldehydes and ketones. All of these are volatile and contribute to the unpleasant odor of rancid fats. Now, let us see the first one, which is hydrolytic rancidity. Hydrolytic rancidity is caused by the hydrolysis of fats into free fatty acids and glycerol by the action of enzymes. The enzyme bring about decomposition of fats. The enzyme lipase is the main cause of hydrolytic rancidity. It can be prevented through heating of the fat to destroy the enzyme and prevent hydrolysis. Contaminating microorganisms may also produce lipase and these can similarly be destroyed with sufficient heating. Fats may become rancid by hydrolytic rancidity when the triglycerides react with water. To avoid hydrolytic rancidity, fats should be stored in a cool place. If possible, lipases should be inactivated. Fats should be kept away from water. Foods to be fried should be as dry as possible before they are added to hot fat. The kind of fat used for frying should be selected based on stability. Now, let us see the second one, which is oxidative rancidity. Fats, when in contact with air, react with oxygen producing products with undesirable characteristics. This is known as oxidative rancidity. Oxidative rancidity is the predominant type of rancidity. In this process, the unsaturated fatty acids are subjected to oxidative rancidity or auto-oxidation. The more double bonds there are, the greater the opportunity for addition of oxygen to double bonds. This increases the risk of rancidity. Auto-oxidation is complex and is promoted by heat, light, certain metals like iron and copper and enzymes known as lipoxygenases. The mechanism of reaction can be separated into three stages, which is initiation, propagation and termination. The initiation stage of the reaction involves formation of a free radical, in which a hydrogen on a carbon atom adjacent to one carrying a double bond is displaced to give a free radical. There is a chemical activity around and in the double bonds. As previously mentioned, this reaction is catalyzed by heat, light, certain metals and lipoxygenases. The free radicals that form are unstable and very reactive. The second, the propagation stage, follows the initial, that is initiation stage, and involves oxidation of the free radical to yield activated peroxide. This in turn displaces hydrogen from another unsaturated fatty acid, forming another free radical. The liberated hydrogen unites with the peroxide to form a hydroperoxide, and the free radicals can be oxidized. Thus, the reaction repeats or propagates itself. Formation of one free radical therefore leads to the oxidation of many unsaturated fatty acids. Hydroperoxides are very unstable and decompose into compounds with shorter carbon chains such as volatile fatty acids, aldehydes and ketones. These are responsible for the characteristic odor of rancid fats and oils. The last, that is the termination stage of the reaction, involves the reaction of free radicals to form non-radical products. Elimination of all free radicals is the only way to halt this oxidation reaction. Now, let us see this next change, which is lipolysis. The blood transport lipids to the rest of the body and cells absorb them and utilize for energy. This breakdown of fat to yield energy is called lipolysis. Now, let us see the next one, which is flavor reversion. Flavor reversion is the change in the flavor of fats prior to rancidity. The refined material develops an objectionable flavor and the edible fats become inedible. The reasons attributed to these changes are exposure of ultraviolet and visible light, heating of the fat, the presence of oxygen for the reaction to occur, triglycerides containing linolenic acid are precursors to flavor reversion reaction, and traces of iron and copper which catalyze the reactions and act as pro-oxidants. Now, let us see the preventive measures to prevent rancidity. Fats can be protected against the rapid development of rancidity by controlling the conditions of storage. Oxidation can be prevented or delayed by avoiding situations that would serve as catalyst for the reaction. The preventive measures are: fats and oils must be stored in a cool, dark environment. Vacuum packaging of fat containing products controls oxygen exposure. Rays of light catalyze the oxidation of fats. By the use of colored glass containers that absorb the acute rays, and fats can be protected against spoilage. Certain shades of green bottles and wrappers and yellow transparent cellophane wrappers are effective in preventing rancidity. Fats also must be stored away from metals that could catalyze the reaction. Cooking utensils used must be free of copper or iron. Lipoxygenases should be inactivated. In addition, sequestering agents and antioxidants can be added to fats to prevent auto-oxidation, increasing keeping quality and shelf life of fats. Sequestering agents bind metals, thus preventing them from catalyzing auto-oxidation. Examples of sequestering agents include EDTA and citric acid. Antioxidants help prevent auto-oxidation with its formation of fatty acid free radicals. Antioxidants prevent rancidity by donating a hydrogen atom to the double bond in a fatty acid and preventing the oxidation of any unsaturated bond. They halt the chain reaction along with the fatty acid, which leads to rancidity. Antioxidants are naturally present in the foods such as vitamin C, beta carotene and vitamin E, which protect against rancidity. Tocopherols are naturally occurring antioxidants that are present in vegetable oils. Most antioxidants are phenolic compounds. Those approved for use in foods include butylated hydroxyanisole, butylated hydroxytoluene, tertiary butyl hydroquinone and propyl gallate. These are all synthetic antioxidants. Use of antioxidants in foods containing fat increases their keeping quality and shelf life. Examination of food labels reveals that antioxidants are used widely in many food products. Without them, the quality of fat containing foods would not be as good and off flavors and odors due to oxidative rancidity would be commonplace. Now, let us move on to the next part, which is technology of edible fats and oils. In that, first is the refining process. The process of refining generally is performed on vegetable oils to reduce the free fatty acid content and to remove impurities. By far, the most important and widespread method of refining is the treatment of fat or oil with an alkali solution. This results in large reduction of free fatty acids through their conversion into high specific gravity soaps. As you can see on the screen, the process of refining is clear crude oil is heated to desired temperature, after which oil is agitated and the caustic soda is added by means of a coarse spray on the surface of the oil. As soon as the amount of alkali necessary has been added, agitation is stopped and then the mass is allowed to settle. The free fatty acids settle in the form of soap, carrying down with them approximately an equal amount of neutral oil. After standing for few hours, the supernatant neutral oil is drawn off, preferably by means of dipping siphon, and washed free from alkali. After alkali refining, the fat or oil is water washed to remove residual soap. The neutralizing agents such as caustic soda, magnesia, lime, carbonate of soda and other alkalis are used for refining. Now, let us see the next technology, which is partial hydrogenation or hydrogenation. Hydrogenation or hardening is the process of adding hydrogen to unsaturated fatty acids to reduce the number of double bonds. The purpose of hydrogenation is twofold. One is to convert liquid oils to semi-solid or plastic fats for greater utility in certain food uses and to increase the thermal and oxidative stability of the fat and thus the shelf life. Hydrogenation is an important process as it provides the desired stability and functionality to many edible oil products. Hydrogenation of unsaturated fatty acid occurs when hydrogen gas is reacted with oil under controlled conditions of temperature and pressure and in the presence of nickel, copper or other catalyst. The reaction is carefully controlled and stopped when the desired extent of hydrogenation has been reached. Under these conditions, the gaseous hydrogen reacts with the double bonds of the unsaturated fatty acids. As the reaction progresses, there is gradual production of trans fatty acids that increases the melting point of the fat or oil and creates a more solid product. The hydrogenation process is easily controlled and can be stopped at any desired point. If the hydrogenation of cottonseed or soybean oil, for example, is stopped after only a small amount of hydrogenation has taken place, the oils remain liquid. These partially hydrogenated oils are typically used to produce institutional cooking oils, liquid shortenings and liquid margarines. Further hydrogenation can produce soft but solid appearing fats which are used in solid shortenings and margarines. When oils are more fully hydrogenated, many of the carbon to carbon double bonds are converted to single bonds, increasing the level of saturation. The resulting product is a hard, brittle solid at room temperature. Now, let us see the processing method of hydrogenation. To dry oil, a small amount of very finely divided nickel is added. Other metals may be used, but nickel is the one most widely employed. The oil with nickel is placed in a tight, strong metal vessel and heated. At the same time, pure hydrogen gas is forced into it until a definite pressure is reached. The vessel contains mechanical device to churn up the oil as the gas passes in. Churning helps in proper mixing of hydrogen gas to all the parts of the oil. The process is interrupted when a sample of oil is withdrawn from the vessel and is found to have desired properties. The oil is then withdrawn and cooled sufficiently and filtered to remove the suspended nickel. The chief uses of hardened oils are in soap, candies. Edible purposes includes margarine, chocolate fats, baking, frying and shortening fats. Hydrogenated fats intended for edible purposes must possess the following characteristics: absence of any objectionable taste and smell. The free fatty acids should not exceed about 0.1 percentage. It should be having satisfactory keeping qualities. A texture, consistency and melting point suitable for the particular purpose should be required. The hydrogenation conditions can be varied by the manufacturer to meet certain physical and chemical characteristics desired in the finished product. This is achieved through the selection of proper temperature, pressure, time, catalyst and starting oils. Now, let us see the next process, which is interesterification. Interesterification or rearrangement causes the fatty acids to migrate and recombine with glycerol in a more random manner. This causes new glycerides to form and increases the heterogeneity of the fat. However, it does not change the degree of unsaturation or the isomeric state of fatty acids. Hydrogenation may be used in conjunction with interesterification and may either precede or follow it. This gives a shortening manufacture the ability to produce fats with a wide range of properties. Now, let us see the last unit, which is fat mimetics. Fat mimetics are substances that imitate organoleptic or physical properties of triglycerides, but which cannot replace fat on a 1:1 gram for gram basis. Fat mimetics, often called protein or carbohydrate based fat replacers, are common food constituents. They may be chemically or physically modified to mimic the function of fat. The caloric value of fat mimetics ranges from 0 to 4 kilocalorie per gram. Fat mimetics generally absorb a substantial amount of water. Fat mimetics are not suitable for frying because they bind excessive water and denature or caramelize at high temperatures. Many fat mimetics, however, are suitable for baking and retorting. Fat mimetics are generally less flavorful than the fats. They carry water soluble flavors but not lipid soluble flavor compounds. The first one under fat mimetics is the carbohydrate based fat replacers. Fat replacements may be derived from carbohydrates with 0 to 4 kilocalorie per gram instead of 9 kilocalorie per gram. Examples of carbohydrate based fat replacers are cellulose, guar gum, locust bean, xanthan gum, gum arabic, pectins, carrageenan, dextrins, maltodextrins and polydextrose. Carbohydrate based fat replacers have many functional roles in the preparation of food products. Carbohydrate based fat replacers are used in baked goods, which helps in retaining moisture and retard staling. In salad dressing, they increase viscosity, provide mouthfeel and texturize the product. In frozen desserts, they increase viscosity, texturize and thicken the product. In margarine, shortening, spreads and butter, they provide mouthfeel. In confectionery products, along with providing mouthfeel, they helps in texturizer. In processed meat products, they increase water holding capacity, texturize and provide mouthfeel. In dairy products, they increase viscosity, thicken, aid in gelling property and helps in stabilization. In soups, sauces and gravies, it acts as thickening agent, provides mouthfeel and texturize. In snack products, it texturizes and helps in formulation. Starches work well as fat replacements in high moisture systems to absorb water and form gels that mimic fat. Some carbohydrate based fat replacers are used as bulking agents to replace some of the volume lost when fat is omitted. A texture modifier changes the texture of a product to be more like fat. Now, let us see the next one, which is protein based fat replacers. Microparticulated protein is a reduced calorie fat replacer supplying 1 to 2 calories per gram. It is made from the whey in milk or egg protein and is manufactured similarly to modified food starch. Protein based fat replacers have many functional roles in the preparation of food products, as you can see in the screen that protein based fat replacers in baked goods helps in texturizer. In salad dressing, it provides texture and mouthfeel. In frozen desserts, it provides texture and stabilize the product. In margarine, shortenings, spreads and butter, it helps to provide texture. In confectionery products, it also provides texture along with mouthfeel. In processed meat products, it provides mouthfeel, helps in water holding capacity. In dairy products, it stabilizes and emulsify the product. In soups, sauces, gravies and snack products, it provides texture. Simplicity is an example made through a process that gives fat like textural properties to protein. Other proteins are heated and blended at high speed to produce tiny protein particles that feel creamy to the tongue. The protein based fat replacers cannot be used as substitutes for oils and other fats in frying. Now, let us conclude the session. Fat is a principal component of the diet. Frying is a rapid heat transfer method that achieves a higher temperature than boiling or dry heat temperature. Fats and oils may be modified by the process of hydrogenation and interesterification. The deterioration of fats and oils occurs as they absorb odors or become rancid. Hydrolytic rancidity releases free fatty acids and oxidative rancidity produces shorter of odor free radicals, which is catalyzed by heat, light, metals or enzymes. Prevention of oxidation by avoiding catalyst in the environment or by the addition of sequestering agents or antioxidants may be useful in extending shelf life. Foods may contain reduced fat, low fat or no fat formulations using a variety of fat replacers derived from carbohydrates or proteins. Fats and oils should be used sparingly in the diet. Thank you.